So I would like to talk about what are the products, back-end products which are provided by ChemAxon, and what are their main features, and also what comes with them. What are the example interfaces that we give with them, and how they are integrated with other ChemAxon products. And at the end, I will talk about the recent developments and our plans. So the JChem family contains 4 products. The oldest one is JChem Base, which was written in Java. It is basically a Java library. And it is the heart of all the other JChem tools. So, for example, JChem Cartridge, which is a wrapper around JChem Base. Indeed, it integrates into Oracle by providing chemical indexes and SQL operators. The cartridge is not only a wrapper for JChem Base, but it also provides an interface, an SQL interface for other ChemAxon functionality, like property predictions and so on. Now, Instant JChem is a desktop tool with a nice user interface. It provides forms and spreadsheet views and so on. It can be used on both local databases in the embedded Derby database, and also it can connect to remote databases, for example, JChem Base or JChem Cartridge databases. JChem for Excel is the youngest member of the family. It integrates into Excel. Now this slide shows the compatibility of what are the different file formats that can be used. So basically, a wide range of file formats can be used, and they can be mixed together. So in the same table, mol files and IZ sketch files and ChemDraw CDX files can be inserted. And the query can take also any of these file formats when we are searching against JChem tables or JChem indexes. Because JChem Base was built as a Java library, it can interact with not only by Oracle as the cartridge, but many other database engines. So MySQL, MS SQL Server, Access, and so on, these are all available. The highlighted ones, I use the bold fonts for those database engines, which are also available from Instant JChem as well. And because the search engine was originally written in Java, it is quite platform independent. So the Java API allows us to run on many different platforms. And during the years, we have also added other interfaces as well. For example, the cartridge itself provides a quite universal SQL interface. But we also, since last year, we have added a .NET API as well. So it is now possible to embed all the JChem components into .NET programs. Also, last year, we have introduced the web services interfaces. This is just another universal interface which allows to integrate with many different languages. The search engine is quite comprehensive. It has lots of different features. On this slide, I just try to highlight some of the goodies that are available here. So we provide a wide range of query atoms. We have lots of query properties. We can handle smarts, recursive smarts. There are lots of reaction searching features. Things like atom mapping and the reaction center can be specified. We can search polymers different representations, source-based and structure-based polymer representations, and also different types of polymers can be represented and searched. Position variation queries, some of the query features are also coming from our Markush technology. The position variation is one of those. And another is the homology groups, which describes chemical classes of substructures. I will have some demos for them later. Okay. We also have an R group decomposition API. It is not yet integrated into the user interfaces. That will come probably next year. And quite recently, we have also just introduced a new full structure search using R atoms. I will show that also later. Okay. In the structure search engine, there are not only all the query features, but the searches can also be customized using different search options. So there are lots of switches that can change the search behavior. I just handpicked a few of them, probably the most important ones. So the stereochemistry can be switched on and off, and we can ignore different features on the molecules, charges, isotopes, and so on. We have different levels of wake bond options. It can allow, for example, to ignore all the bond types, or to allow to match all the ring bonds to aromatic bonds, and so on. We also provide a unique chemical terms filter. Chemical terms is a language designed by ChemAxon, and it can be used to express chemical expressions. The expressions that can refer to our property calculations, for example, molecular weight, log P, log D, pK, and so on. And on this, in this portion of this dialogue, there is for example, a drug likeness filter. So things like the Lipinski rule of 5 can be easily formulated using this language. We also have different methods for tautomer handling. I will have a separate presentation about those methods tomorrow. And there are many IT-related options as well, which are not so much related to the structure itself, but that can just limit the search type of the search time or the number of hits, or combine the structure searching with searching other fields in the database, and so on. Okay, this slide shows some performance data. So the top table shows registration times. Now this is using SMILES. The SMILES format, the mol5 format takes a little bit more longer, or the other more verbose formats, because the data has to be moved into the database during that. So you can see that even hundreds of thousands of structures can be registered within several minutes. So it's quite good. And also the structure searching is also quite efficient. This data uses the PubChem database, nearly 20 million compounds. And here the search time basically is proportional to the number of hits that are returned. But you can see that up to a reasonable amount of hits, the search takes just a few seconds. Yeah, the hardware where these data are measured, it's a 4-processor, 3-year-old machine. So probably with the latest many CPU servers, you can achieve even better performance as well. Okay. JChem Cartridge and JChem Base offer different types of tables. So we can create molecule tables which will, on one hand, filter so the table type on one hand may filter the content which are allowed to insert it into it, but some of the table types also provide some special operations. So molecules are for storing specific structures, but the specific structure may mean salts or mixtures or coordination compounds and polymers and so on. But for example, query structures or Markush structures are rejected from molecule tables. The reaction table stores single-step reactions, which can have like atom mapping and reactants, products and agents. And one special operation or reaction tables is, for example, a reaction similarity search. And we have different kinds of reaction similarity measures, like we can search for reagent similarity or product similarity or the transformation similarity and so on. The Markush table type is used to store Markush structures. I will have a separate presentation about that tomorrow, and we will have a long discussion about that on the Markush forum. The query tables are used to store query structures, and the main operation for a query table is superstructure search. So basically, the query for a query table is a specific compounds, and in this case, we retrieve those queries in the database which are substructures of the specific compound. And the any structure table is the joker. Anything can be inserted there, and there are no special operations on them. We provide several example data interfaces with JChem Base. One is a Java Server Pages interface. You might use it. You might know it from our web page, but we also have an Ajax, a more modern Ajax example that communicates with JChem Web Services. JChem Base and Cartridge can also interact with many other ChemAxon products. Well, one of the first products that was integrated is standardizer, so that the compounds that are put into the JChem tables can be standardized to bring into a common format. We also integrated calculator plugins in several ways. I have mentioned the chemical terms filtering features at the searching slide, but we can also provide calculated columns. And for these calculated columns, we also use a chemical terms expression. And when the calculated column is set up, then when a structure is inserted into the database, that calculated column is automatically filled. And every time the structure is changed, the calculated column is recalculated. So it means that the column is always up to date and relates to the actual compound. Screen can be used for different similarity types and metrics. One of the most recent descriptors which is coming this year is, for example, the extended connectivity fingerprints. Okay, the Tautomer plugin is also integrated. I will talk about that tomorrow. And finally, Marvin, the drawing package, provides the most compatible query drawing interface. So Marvin can represent every query that JChem understands. Some cartridge goodies. This slide shows what functionality the cartridge provides in addition to JChem Base. So it provides the JChem index, which allows an arbitrary table structure. So in the cartridge, we are not limited to JChem tables, but an arbitrary table structure can be used. It also communicates with the optimizer and provides interface for several other things like reaction-based enumeration, format conversions, Markush enumeration, property predictions, and so on. And one new thing with the cartridge is the use of user fingerprints. So when there are user-defined bit strings for the fingerprints, for example, for an in-house algorithm to create your own fingerprints, we can make use of those bit string columns and do similarity searches against them, and so on. Okay, Microstructure handling, I will talk about that tomorrow, and let's see what is new. So in the 5.3 series, we have just introduced the homology variation possibility in queries. So now all these can be used in the queries. We also added a new R group decomposition API. So when JChem search, when a substructure search has been done in JChem search, then it is possible to get an R table relating to that substructure search. And we will add a user interface in the next year for that functionality. For this R group decomposition, and also for R group decomposition on molecule objects, we added a new output to create a Markush structure directly from the R table. So it's not just a tabular R view can be displayed, but also a compact Markush structure can be created from it. And then that can be fed back to our other Markush tools. I have mentioned the new R-atom matching feature. I will have a demo of it later. And we have added some new wake bond level options and reduced the memory for the atom-by-atom searching. On the IT side, we have added several other improvements. For example, now we allow a batch pre-regeneration of chemical indexes and JChem tables. Now this is useful for the support people to reduce the downtime during version upgrades. So when a new JChem version comes out, now in batch mode, it is possible to regenerate the table while the old system is still running. And then when the tables are regenerated, the switch can be done in an instant, basically. We have added several user interface improvements into the JChem Manager program. JChem Manager is our administrative interface. So for example, we have integrated the standardizer GUI, and also it is now easier to create molecular descriptors to use different kinds of similarity measures on JChem tables. And we have also added a new method for handling log tables and register different cache instances. It is useful when JChem is used in a highly transactional manner in multi-user environments. So these new logging mechanism ensures that the cache updates are as small as possible. The cache update times are as small as possible. Okay, on the cartridge side, these are the new functionalities. basically our Markush functionality has been integrated into the cartridge, so it's now available by SQL operators only. And the user-defined fingerprints I mentioned before. We also just added integration of the screen descriptors, so it is possible to different types of similarity searching now in the cartridge as well. And we have also added some new security and new exception handling features as well. Okay. And we have many plans. So the top few stuff are already implemented, and they are coming out in the excuse me, coming out in a month or two. So we have just added some multi-threading of the fingerprint operations. It means that the similarity searches will be faster, and also the screening stage will be faster as well. It means that the first results will appear more quickly on the output. We have a new highlighting for similarity search results, and for that we use our maximum common substructure algorithm. It's a kind of new visualization of similarity. But it is only a visualization. The similarity is calculated the same way as before. So it's in R group decomposition, we have added a new method to handle symmetrical scaffolds. It means that the R table which is created is much more logical, so that for example, the non-hydrogen substituent will be always matched to the first R group and things like that. So it will be much easier to see the R tables with these symmetrical molecules. And we have also just added some homology properties for the homology groups. This is again coming from our Markush technology. I will talk about that in more detail tomorrow. And there are many other things that we have in plan. For example, we are planning a maximum common substructure search type, not just for visualization, but real searching. We plan R group decomposition user interfaces into IJC, Instant JChem. It is already there in JChem for Excel, but we will add it to the example web applications and so on. On the longer term, we are planning to support an arbitrary table structure or the JChem index in JChem Base directly, not just in the cartridge. And we are also planning to add some grid solution or computational cluster, so that more than one or many CPUs can be added to the JChem server. And this will be particularly useful for our Markush project, where the structures are really complex and searching can take some time. Okay, and in the cartridge, yeah, there are other things we want to incorporate. For example, the R group decomposition again, and further speed improvements, which will overcome some Oracle limitations we want to add. Okay, let me just show some demo of the newest features. So this is Instant JChem. First, I will show the homology groups. So an alkyl atom is put there as a substituent and searched in the database. It is the NCI database, so we can see that some alkyls are nicely matched, a methyl and the longer alkyl chain, and so on. and this alkyl can be substituted. Now let's put, block the substitution on that alkyl. So we put on a query property. The S query property stands for the substitution, and the S star means that substitution has drawn. It means that there are no extra substitute, only that one is allowed, which is in the query as well. Okay. Okay, and we will see that on the result, there are only non-substituted alkyls. Okay, on that position. When there are more than one atoms matching to the homology group, then it is drawn by green. Okay, we can just draw further that query. We will put on another homology group. Yeah, this template group contains all the supported homology groups. So we will put a heteroaryl group next to that nitrogen. And let's do the searching. Okay, so we can see our ring structure, an alkyl, nitrogen, and it is connected to a heteroaromatic ring. Okay, so we've got this. Let's just delete this and draw another query using R atoms. Now, if the R atoms are not have definitions, in that case, it means that we are looking for a full structure. So in this case, the cyclohexane ring are not allowed to be substituted, only where the R was specified. So let's look at another substitution pattern. So we put R there and R2 on this position. Okay, so we only get back those substitution of the cyclohexane. Now, if the same R number is used, so R2 and R2, then we will get back only this symmetrical structures. So yeah, we can see that all those substituents are the same. Okay. And a new feature is that there were many limitations on the R groups. Yeah, oh. Now we will, yeah, okay. This is a position variation which is being drawn. So that carbon atom can attach to either of those positions. The highlighting can be seen here? Okay. So we can see all the different positions are retrieved. Yeah, and some limitation of the previous R group handling was that this multiple many attachment many bonds could not be used. Now it is eliminated, so we can use that. We've got this larger R, and that is connected to a double bond with an oxygen and the chlorine. Okay, and the last thing is a repeating unit that I want to show. Here we put up a bracket, and we say that the repetition should be 3 to 5. Yeah. And this is the dialog for the other bracket types. All the polymers are here. Okay, let's run this. And so we can see that it matched all those. Okay, that's all. So to sum up, we have seen the JChem backend products, JChem Base and Cartridge. They are quite comprehensive and effective. And they are good team players. They can interact with their other ChemAxon peers, but also they can work very well with other non-ChemAxon software pieces as well, because of all these compatibility features and so on. And there is continuous development and improvements still in the pipeline as well, and have been added in the past few years. Thank you for your attention, and I'm ready for your questions.
Matthew Pustelnik, Decatur, San Diego. One of the things that I noticed that was missing from the future, I guess, efforts for ChemAxon. Last year, you guys talked a lot about 3D shape searching. I noticed that wasn't there. Are you guys moving away from that?
No. Tomorrow, Miklos will talk about a new 3D overlay method. It is not, I'm not sure whether it's shape searching, but it is a 3D overlay method. And it is, as far as I know, it is not yet integrated into the cartridge. But if there is a need for that, we are certainly open for that. But it is already available as a component, as a software component.
My second question is related to your grid computing. Are you guys investigating also GPU processing?
Yes, I have looked at that because I know that it is a trend in the industry, and to use GPUs for speeding up scientific calculations. However, what I saw is probably not enough for us, because the GPUs are customized for floating point operations and for very high speed, very small granularity tasks like floating points. For a lot of things that we do is not related to floating points. So we do a lot of discrete programming and graph matching and this kind of stuff, which is probably not suitable for the current GPU architecture. What could help us if the JVM would be ported to a GPU, then we could easily port some portions of the JChem server into that GPU architecture using JVM, the Java Virtual Machine. But I don't know how close that is.
Thank you.